Okay, so this is kind of how to do your Bohr-Rutherford diagrams that you should have done last week. But if you didn't get to them or you were confused on how to do them, I want to make sure that you know how. So I don't know if you've noticed, but I keep pulling out my periodic table because you need this for everything. So I printed off 2 of these in case I make a mistake. So I'm going to put one to the side. So what you need to have is, you know, from the periodic table here, that hydrogen has 1 proton. And you know the mass number is 1.01 is our atomic mass. That would round to 1. So 1 minus 1 will give us our number of neutrons, which is 0 neutrons. So inside of here, you should write 1 proton, 0 neutrons. But that's kind of hard to see, so I thought I'd write beside here as well, 0 neutrons. So we're going to need to do this for every single element. I'm going to do it for a couple just to make sure you guys know what to do. So for lithium, it has 3 protons because our atomic number is 3 and our mass number is 6.94. So 6.94 is like saying 7 minus 3 equals 4 neutrons. So I'd have 4 neutrons here, and these live in our nucleus, which is 3 protons, 4 neutrons. Let's do sodium. So sodium is 11 protons, and our mass number is 22.99, our atomic mass, which is like saying 23 minus 11 is equal to 12 neutrons. So over here I've got 12 neutrons. Now just be thankful that we're only going up to 20 and not going up to like 118 doing this. So last one that we will do here is potassium, which has 19 protons. And it has 39.10 as its mass number, atomic mass, which means that we have 39 minus 19 is 20 neutrons. Some people may say, Miss Young, can we have a calculator? Of course you can. I don't care if you can do the math in your head or not, just that you know how to do it. So again, I didn't put these in here. So 19 protons, 20 neutrons, 11 protons, 12 neutrons. So our inner circle is our nucleus. Okay, I'm going to speed this up so that you can see them faster. Okay, so that sped that up a little bit, and hopefully you guys can read all of the things that I've written. And now we're going to need to put on our electrons. So you have, for all atoms have the same number of protons as electrons. So here you're going to have 1 proton, so you have 1 electron on that first shell. The other thing that you need to know is that your first energy level, shell, orbital, they're all the same thing, can hold 2 electrons maximum. Your second energy level can hold 8 electrons max. Your third energy level can also only hold 8 electrons max. And then your fourth energy level can hold 18 electrons max. Now, the other thing that you need to know about your energy levels is you have to fill one energy level before you can move out. So before you can go out to the next. So hydrogen has 1 proton, so it has 1 electron. Helium has 2 protons, so it's going to have 2 electrons. Lithium has 3 protons, so it's going to have 2 protons in the first and 1 in the second. Beryllium has 4, 2 in the first and 2 in the second. So I'm going to draw my energy levels or my electrons for the second energy level and the third energy level so that they go around like a clock, like 12, 3, 6, and 9. And then as I increase them, I'm going to go around again so that they'll get full. So for the next one, beryllium has 5. So 2 together because that one's full. And then 1, 2, 3 on the outside. Then when we go to carbon, we're going to have 2, and then we'll have 1, 2, 3, 4 on the outside. So it's got our 6 protons and our 6 electrons. Nitrogen is going to have 2 on the first level, and then it's going to have 5 on the second level because it's got 7 protons. So 1, 2, 3, 4, and then 5. So these become a lone pair, which you don't really need to know what that means yet. You just need to know that they go together. So the next one, oxygen, has 8 protons, 2 on the first level, which means that we have 6 for the second level. So I do my first 4 first, and then I come back and pair up these 2. Then for fluorine, I've got 2 on the first level, and then I'm going to have 7 on the next level. 1, 2, 3, 4, 5, 6, 7. Neon's got 2 on the first level, and then 2, 4, 6, 8. So here's some important things we should be noticing first. This one has a full shell on the outside. This one also has a full shell on the outside. It's very interesting. Okay, let's go over here. So now we're at sodium. It has 11. So I'm going to put 2 on the inner shell and then 8 on the next one. And then I'm going to put 1 on the one outside of that. The next one I'm going to put 2. We're going to need to have 12 this time. So we're going to have 8 on the next one. And then I still have 2 more left over. So I've got 1, 2. And I'm not putting them as a pair this time because I want to show you why in just a second and how the chemistry works. So we're going to have 2 here, and then we've got 13. So 2 and 8 make 10. And then I will have 3 on the outer shell. And here I'm going to have 2, 8, and then I will have 4 on the outer shell. And this one I will have 2, 8, and we're looking at 15 this time, so I'll have 5 on the outer shell. And here is 16, so I'll have 2 on the first shell, 8 on the next shell, and 6 on the shell after that. 17, I'll have 2 on the first shell, and then we'll have 7 on the shell outside of that. And next one, 2 here, 8 here, And then we will have our 8 on the outer shell. And look, again, we have the magic of this being full. That is not how you spell full. Just gonna write it above here. I got really excited. Full and excited, so I started writing with an E. Over here, we're gonna have our 2, then we're gonna have our 8, and then we're gonna have our 8, because we need to get up to 19. So that gives us 18, and 1 on the outer shell is 19. And here we're gonna have 2, we're gonna have 8, we're gonna have another 8, and then we're gonna have 2 out here on this shell. Now, the most important thing that you guys need to know from this is that you guys are noticing the pattern. All of these ones in the first row here, these ones all right here, these all have 1 electron in the valence. Valence means outer energy level. Okay, so they all have 1 electron in the valence level, which means that underneath there, like they've got a full shell and then 1 extra. This one has 2 full shells and 1 extra. This one has 3 full shells and 1 extra. So that's really important in the chemistry. There's another thing that we'll go to in just a second. So that's here. Now, if you look at this one, what do you notice about those? What do they have in common? So these ones here, they all have how many in their valence shells? So I'm hoping that you're answering out loud. I mean, I love that you hope that you would be answering out loud. So these ones all have 2, I'm trying to figure out where to write them, 2 electrons in the valence energy level. Then you will notice as we keep going across, these guys here have 3, and then we're just going to start calling them valence electrons. So you just can write 3 VE, 3 valence electrons. Then when you get over to the next one here, these ones have 4 valence electrons. And the next ones have 5 valence electrons. And the next ones have 6 valence electrons. And the next ones have, why can't I find another color? Oh, it's because I threw them all on the floor in the other video if you were watching them. And this one has 7 valence electrons. Now there's some other things that are really important with these. So this is 1 valence electron, and this is all called group 1. 2 valence electrons is group 2. Now it's not the simple as the next one is to group 3. No, we have to have those transition metals in there. They kind of get in the way. So you'll notice these all kind of come here. So then we come over here, and this is group 13. This is group 14. So when you get to these, you kind of just lose that 1. It doesn't count as much. This is group 15, group 16, group 17, and then these, although these are all full, we don't call them group full. We call them group, although we should, that would be a way better name, group 18. So that's really important. Now, I have one more thing to write on here because this is getting super full, and I'm sorry about that. But one other thing for you to notice, As we go across here, you should be noticing that we are filling our energy levels. So our first energy level has 2 electrons maximum. And look, there's only 2 elements in our first period or our first row. That is because these energy levels are the periods. So I don't know where to write this. So period 1 is energy level 1. So this is period 1. Period 2, we use 2 energy levels. Period 3, we use 3 energy levels. And period 4, we use 4 energy levels, etc. as we go down the periodic table. So these periods that we wrote in here are actually telling you not only what row on the periodic table, but how many energy levels you are using. So the more you learn about the periodic table, the more it can tell you about the elements within it.